Hi, I'm Alan Hansen here at Minnesota State University, Mankato. I'm working with Roy Anirban on our senior design project, which is an internet-controlled spy robot with a live feed camera. And there's the guy down there right now. It's just a simple RC car that's been stripped of all its components. What we did is we tore out all the radio components. We left the motors, which are fully functional. Inside we have the L298H bridge, which is controlling the motors. On top of that, and underneath the plywood plank here, we're going to have our 7260 microcontroller from Embedded ARM Systems, which is programmed to run the H bridge. We have a power supply, two power supplies, one for the components and one specifically for the H bridge. These are 8 nickel metal hydride batteries, producing 1.2 volts each, around 10 volts total in series. We have the TrendNet IP 100 network camera, and all of this is being connected to our Linksys router, the WRT54G version 2. Ethernet ports are coming from the microcontroller and from the network camera to the back of the router here. And I've established a wireless bridge which is going to our home gateway over here. Pretty standard router we got. It's a little bit newer than the one I have on the router bot, but this is the Linksys WRT54G2 version 1. Cable modem, internet access, so that's all good to go. Both of these routers have the DDWRT firmware installed on them. It wasn't necessary at first to put the DDWRT on the home router, but it became a necessity later when we realized that we needed it for port mapping. So we have a wireless connection between the two routers. You cannot do, with the stock firmware, you can't do a bridge connection, so we did put those new drivers on there. So I'm going to go through a quick demonstration of how the robot works. First, we're going to start the main power supply here, and this is going to power up the TrendNet camera and the router. The router is going to acquire a DHCP address from the main router, and it will feed it to the TrendNet camera. It takes about 30 seconds or so to fire up, so we're going to let it do that. While we're doing that, I'm going to launch a browser here to get ready to view the live feed camera. I've set up static DHCP on the home router, which means that the same IP address will be used for the devices on the router every time. That's used with the MAC address there, because that's the only one unique address we have on there. Here we have the server, which is on the TrendNet IP camera. We're going to click on the Java button here and get to the live view. We'll give it a second to load up, but there is our live feed camera. I'm going to keep it on here. I'm going to move around a little bit to show you that indeed we do have a live feed down here on the floor. Next, I'm going to power up the microcontroller. The reason why I have to wait until afterwards to power up the microcontroller is because it too has a DHCP search, and it will need to get an IP address from the main router. If they turn it on at the same time, of course, the bridge router will not have established a connection yet. Therefore, the microcontroller will go through its normal startup and won't be able to acquire an IP. It's not smart like that. We're just going to keep looking, so you have to wait a little bit to fire that up. It takes about 30 seconds, and we're going to log into that through Telnet. Has a Telnet server on there, port 23 here in the house, and port 2323 everywhere else in the world. You don't have to use Linux for this, even though I am. One big note here in the project is that all this was done with free software. I didn't pay a dime for it. Ubuntu, the main server I'm running here for the operating system, was free. Of course, the Telnet is free. It has been for a while. But you can use Windows or Apple to log in and control these devices. Address here for the microcontroller I set at 130. Enter in the password. So now I'm logged in the microcontroller. I'm going to launch our program here, our C program on the microcontroller. Next, I'm going to power up the H bridge over on the car itself. So now that closed the circuit here in the second power supply, so now we have power going to the motors. Now the RC car that I do have, of course it's used. It's an old one from my childhood, and it is broken in the sense that the transaxle, the piece of plastic that controlled the steering, is broken. So right now all it's going to do is go forward and backwards. If the plastic piece was not broken, we would definitely take a tour of the whole house, but it's a very good proof of concept we have going on here. So I can enter in a 1 or a 0, forward or backwards. And right now we're just going to enter in a 0, or a 0 here. And in duration of travel, let's say 1 second backwards. Go ahead and take a shot of the car. In fact, I'm going to get down here in front of the camera and show myself typing here. I'm going to hit the enter command and it should go in reverse. Indeed. And once again, I'll have it go forward now for 2 seconds. It should come at me. So that's the whole gist of the operation. The budget was under $230 for everything all said and done, and I think it worked out really well, what we have going on here. The batteries were commonly available, and usually the cheapest is the best, so that's what we went with. It should have a runtime for about an hour or so. Things we could do in the future, probably a charging station to have it go back to its home and recharge while the user's away. Now I did test this. You can log in from outside, of course. That's the whole point of this project, for home monitoring, things like that. You can log in from anywhere in the world to the house and to your router bot. I couldn't do the presentation at school because the school has a certain encryption that wouldn't allow the bridge router to connect to their network, so I have to do the video demo here. Thank you for your time.